Welcome to qnawire.
Binding energy is the energy involved when the nucleons, or the protons and neutrons, combine to form a nucleus. This energy comes from something called the mass defect. The mass defect is the difference between the mass of a nucleus and the sum of the masses of the protons and neutrons that make up the nucleus. You would expect that the mass of the parts should equal the mass of the whole, but we see that there's a slight difference. And this difference is due to the fact that some of the mass has been changed into energy, or the binding energy. So this is the binding energy, and this is the mass defect. When we talk about describing the relationship between mass and binding energy, there are several different relationships that we can use. One atomic mass unit is equal to 931.5 mega electron volts, which is an energy unit. And a mega electron volt is equal to 1,000,000, or 1 times 10 to the 6 electron volts. And we can relate electron volts to joules. 1 electron volt is 1.602 times 10 to the minus 19 joules. So if we can find the mass defect, we can calculate the binding energy. If we have a given nucleon, so in this case we have cobalt 59, and we know its actual mass, atomic mass, is 58.933198 atomic mass units. We can find the mass of the particles. The atomic number of cobalt is 27, which is found on the periodic table. So that means there are 27 protons that make this up. The number of neutrons is the mass number, 59, minus the number of protons, the atomic number, 27, or 32 neutrons. So the mass of one proton is 1.007825 atomic mass units. And the mass of one neutron in atomic mass units is 1.008665. So if we take the number of protons times the mass of protons plus the number of neutrons times the mass of one neutron, we find that the mass of the parts is 59.4885553 AMUs. So our mass defect is what the mass should be if we added up all the parts, minus the actual mass, which was given to us. Or in this case, 0.555357 AMU. Now that we know our mass defect, we can change that to electron volts. Because there are 931.5 mega electron volts for every 1 atomic mass unit. Or 517.3 mega electron volts per atom. So this is the binding energy per atom. If we want to find the binding energy per atom, we remember that there are 27 protons and 32 neutrons for a total of 59 nucleons. So for every 1 atom, there are 59 nucleons. So 517.3 mega electron volts per atom times 1 atom per 59 nucleons. Or we divide 517.3 by 59. 8.768 mega electron volts per nucleon. If we want to change our binding energy from electron volts per atom to kilojoules per mole, we can do that using the conversions given as well. We're going to start off with our 517.3 mega electron volts per atom. And I know that there are 6.02 times 10 to the 23rd atoms per mole. And there are 1 times 10 to the 6th electron volts for every mega electron volt. And there's 1.602 times 10 to the minus 19 joules per electron volt. And finally, 1 kilojoule is equal to 1,000 joules. So if I multiply 0.17 times 6.02 times 10 to the 23rd times 1 times 10 to the 6th times 1.602 times 10 to the minus 19 and divide that all by 1 times 10 to the 3rd, the answer is 4.989 times 10 to the 10 kilojoules per mole.